Proposition 251. Singularities exist only on paper and in formula, but not in the physical realm. You can never place within any bounded area of space or time an infinite amount of relative mass or infinite amount of relative energy or infinite amount of relative time or infinite amount of relative space. Singularities do not exist in nature and crop up in spots where we do not yet have our physics correct. Proposition 252. There was no singularity at the start of our Big Bang. There are no singularities at the center of the event horizon around each black hole. Time does not stop if moving at the speed of light. Moving faster than the speed of light does not cause you to move backwards in time. When things approach infinity, besides the totality of space or time, then we have likely made an incorrect conclusion along the way because the physical realm is always relative. Proposition 253. At the center of every black hole is a large polyquark or dense quark soup. Quark degeneracy pressure relies on immense gravitational pressures to turn neutrons into quarks, where the strong nuclear force, which is 100 trillion times as strong as gravity, takes over. The dense central polyquark grows as it absorbs mass, and in turn, the surface area of the event horizon would grow proportionally. Proposition 254. Hawking radiation does exist, and one of a pair of particles created could escape the event horizon of a black hole. However, this does not lead to a black hole's evaporation over time. While it is true that there is a thin sphere just inside the inner edge of the event horizon, where one of a pair does escape, however, there is a sphere of marginally larger surface area where the pair production occurs outside the black hole and one of a pair is sent into the event horizon. Black holes do not evaporate, and the root cause of Hawking radiation actually increases the black hole's mass over time. Proposition 255. There are solutions to the field equations of general relativity that likely do not exist in the physical realm. Singularities, white holes, and wormholes could all be mathematical constructs that may appear elegant on paper, yet lack any true physical existence anywhere across space and time. Proposition 256. White holes, if they ever actually do manifest in our physical realm, are likely tiny and transient. They cannot be self-sustaining, and their dissipation likely occurs at an exponential rate based off mass. Far more likely, they have never and will never leave the pages of formulas and equations. Proposition 257. Wormholes, if they ever actually do manifest in our physical realm, are likely tiny and transient. They are non-traversable, likely collapse easily, and they could never offer an ability to traverse light years of space in fractions of the time. At best, before a wormhole collapses, not that it would be big enough to send more than a molecule through, we might see light-second traversal of space, but never light years. That is, if they even manifest at all, which is highly speculative. Proposition 258. The arrow of time flows in one direction only. No matter how fast you travel, you will never traverse the line of time in reverse. No matter where you end up, you will always be at some future moment in time from the point you left, no matter your speed. However, time machines are actually very common, and almost every one of us has ridden in or on one before. Any mechanical device that you enter or step onto and then exit at some future point in time could be considered a time machine that transported you into the future. None will ever bring anyone or anything into the past. Ever. Proposition 259. The subquantum realm has an average energy density and mass density, and what we see inside our visible patch of space-time might be far denser than what we find in the areas between similar pockets of space-time. In the area between our universe, and the siblings it is playing follow the leaders in our next largest co-moving frame of reference, the energy density of the subquantum realm would be predicted to be lower. We would also predict the distribution of neutrinos would decrease in those areas farthest from any other pockets of spacetime. Proposition 260. Mass and motion moves in waves, and subquantum mass and motion moving relatively faster than our cosmic speed limit creates subquantum waves of energy. All waves of energy have a general trajectory but try to spread out in all three spatial dimensions. Sometimes waves of energy can deflect, reflect, diffract, refract, polarize, and synchronize in phase. Proposition 261. In order for waves to be in phase, one or more polarizations that are present in parallel moving waves must be synchronized to see waves of energy increase in amplitude. The mass energy density of the subquantum realm within an area would define the types of polarizations seen as well. When there is sufficient subquantum energy density for a fine structure constant to produce quanta that we can measure, we get particles of the standard model. Proposition 262. Areas where the subquantum energy density is too low, no fine structure constant would be present to see atoms and electrons form. Areas where the subquantum energy density is too high will likely be located inside the event horizons of supermassive black holes. In between, we see aggregations of subquantum energy manifest as our standard model of particles and the quantum fields that describe how they interact. Proposition 263. Quantum fields do not magically exist without having an underlying cause. That cause is a realm far smaller than the electron neutrino in quantities likely far higher than all neutrinos. For each of the trillions of neutrinos that pass through us every few seconds, hundreds or thousands times more subquantum waves of energy also pass through us. Proposition 264. Separate quantum fields may make the math of physics easier to visualize, but there is a single field of energy, the fifth dimension. That dictates how and where aggregations of subquantum waves of energy in phase coalesce as a measurable unit of quantized energy at our scale factor to create stable particles. Proposition 265. Energy moves in spherical waves, so polarizations can happen in more than two spatial dimensions. How those subtle differences occur within synchronized polarizations needed for waves to be in phase may play a part in whether we get a stable particle or a virtual particle. Proposition 266. Alongside the differences in how three-dimensional polarizations and synchronization can aggregate in phase, combined with the different density distributions of the subquantum waves of energy, will someday point to frequency and vibration being the resonant resonance of existence. Tesla saw this over a century ago.